All right. Thanks for joining us today. I'm Mick Sass. I'm one of 6 inspectors with RVIA, and I'll be giving you this presentation today. Today, the subject is going to be from the NEC under Section 551.47 G, I, and J, and it all has to do with cable protection and securement. To get all of the information, hopefully you have or are going to get in short order the new 2017 NEC edition, and you can look up this information in more detail there. For all of the RV people that we have on the webinar today, the NFPA 1192 handbook, the guide to that information is under the 120 volt section in here, and it does expand on the language that you do see in the NEC. So to get started, we're going to start looking at actually the physical protection portion of this, and that would be under 47G. Steel protection is required for non-metallic sheath cable, which we normally refer to as Romex. And if it's passing through, if the Romex is passing through wood framing that has a width of less than 1.25 inches on either side of where the Romex is, then it's going to need some type of a physical protection. This is only true for the 120 volt side of an RV electrical system. It is not necessary for anything to do with the 12 volt side. Here's an example of the way to do it and the way not to protect using a sleeve in this case. All of your sleeves or smash plates that we'll show you in a minute are going to be of a 16 gauge metal, and they show on the right here a hole going through a very narrow stud in the wall, and you obviously do not have 1.25 inches on either side of that hole. So on the left-hand photograph, you see a sleeve that penetrates completely through that stud and is giving full protection to any Romex that goes through that section of wood. If the stud is so narrow that you can't use a sleeve and pound it through without breaking the stud, then you do have other options. You can get smash plates, like you see on the photograph on the left. That can be placed on one or both sides, and there are smash plates that are created to go into dados rather than to just go through a hole that's been drilled. All of these methods will serve to adequately protect the 120 volt wiring as it passes through your wooden studs. Here's an example of where the sleeve doesn't get installed properly. It's not going all the way through this stud. And whether you have one stud here or if you got 4 studs that are stacked next to each other to provide more structural strength for a portion of the coach, you need to have the steel sleeves pass completely through the studs. And if you take a look at the photograph on the right, it's easy to see that the edge of the sleeve did not make it all the way through the stud. And the top sleeve on the left photograph obviously didn't make it all the way through the wood stud as the one on the bottom did. And so that's not fully protected. It would be a deviation. Here's another example of something that has to do with protection. Even though we don't have a specific deviation, the slots, the seam of the sleeves in these cases should be positioned in such a way that it's not going to be directly facing an area where a nail or staple or a screw could come through and damage the Romex. So common sense states that you should get these oriented in such a way that you don't have that potential damage to the Romex. So beyond that simple portion of common sense with physical protection, The only other way that we worry about at this point with 47G is the routing of Romex wire. And this generally has to do with your cabinets. The cabinets are generally built quite lightweight. The cleat stock that they use is narrow, and so to use a sleeve or even to use a smash plate, it's not really practical. The only way to really protect your wiring is through routing. And as you see in the illustration on the right, we've placed the routing of the wire to the far back near the outside wall and to the front of the cabinet as close to the front pleat as possible, leaving that center section open for an RV owner to install a towel rack or something that may go in the center, but it's definitely not going to go on either edge real close to where the wire is. So routing is the other way of protecting your Romex wire in a cabinet situation. When we start looking at the use of aluminum studs, we're not really worried about, you know, a nail or a staple necessarily being the damaging thing to the Romex. It's going to have to do more with sharp holes and burrs that may be left over when you are actually drilling the holes through the aluminum studs. So in those cases, again, we're back to the point where we're going to just try and protect the Romex. You can use a number of different items. Most everybody is going to use something like the black grommet that you see there. They click into position. They're not going to be falling out when they're being vibrated down the road under those kind of conditions. The white sleeve will pass well through it and should stay in place well. The protection is also can be provided by PEX tubing or any other type of, say, a watertight conduit, kind of expensive, but it can be used. Anything that protects the sharp edges from the metals holes is what we're trying to accomplish when we're going through the aluminum framing. So then we're going to move right into 47I, which is going to start talking about the securement of your Romex in relationship to, in this case, outlet boxes, panel boards, splice boxes for other appliances that actually go into a cable clamp of one of those devices. And this 12-inch dimension is for all the devices, again, that are using a cable clamp in the device. And these are the types of cable clamps I'm referring to now. There's a few of them out there, and all of them should be reviewed when you get them if you're not familiar with them, to make sure that they're being installed in the right type of device and being installed in the proper method. Again, always go to your installation instructions to make sure that these things are being used properly. These are two very common ones. We see them all the time. So when we start talking about one of the definitions that we need to look at, it's being secured, and secured means held in place, and that can be a wire staple, a clamp, a zip tie. There's several means that you can use to secure a section of Romex, including a stud sleeve where it passes through. It's actually being supported, but that small amount of support is actually called securement in this situation. And secured, as we'll see here, is not just laying on a surface. The example you're seeing here, it's certainly supported, but it's not secured as it's laying in the roof section of an RV, and you have all kinds of Romex going across the unit, but it doesn't have any securement. And where's our securement supposed to be? Every 4.5 feet. So again, this is a place where we need to do and consider securement almost the same thing as support. You got to have securement every 4.5 feet, and that would be a cable clamp or a strap or a zip tie. When we are looking at the devices that use cable clamps, like you see on this combination load center, you see the P-clamp at the bottom next to the red arrows, and that is easily within 12 inches of that device. And it's a straight line dimension. We always measure in a straight line. And for any device that uses a cable clamp, like this gray ones that you see at the top of the distribution panel board, you need to stay or maintain that 12 inches at a maximum distance from the device. And again, it's measured in a straight line from the nearest point of the clamp to the device itself. That allows you to do things such as this. Pull the distribution panel out, do some maintenance on it, get to other components that may be behind the unit. If you didn't have 12 inches or some even longer dimension to bring that out, you have a hard time getting to those types of areas and doing the work that may need to be done. Here's an example of a splice box on the back of a water heater. And again, you can see that the red arrow is pointing to the cable clamp on the splice box itself, and the other end of the arrow is pointing to the clamp or the crimp that is actually holding the other end of the Romex within 12 inches. It's fine. It does everything it needs to do, and that's a good installation. It could be as simple as a metal 4x4 J box that you see here. You've got the plastic cable clamp coming in, the Romex is in place, they've installed the cable clamp properly, and so within 12 inches of that box, at some point, you need to have a zip tie, a cable strap of some sort holding it in position. Going back slightly to the 4.5-foot dimension for securement, we're now looking at a vertical wall. And in this vertical wall, you can see that there's nothing supporting and securing that cable within 4.5 feet of where it passes through the top plate of the wall. So that would be a problem. You'd have to bring the stuff over to the wall, get those white clips and secure it. One way or another, there needs to be securement within 4.5 feet in the vertical or in the horizontal runs of Romex. So we'll move on to the other dimension, and this is under 47I, and this is an 8-inch dimension. Again, that's going to be measured in a straight line, but this is for all of your non-metallic boxes, your self-contained devices that are plastic, and they do not have cable clamps that we've been working with in your transfer switches or your distribution panel boards that we saw earlier. Here's a couple of examples. On the left, you got just a regular offset box, and you can see that the Romex is being secured with a white P-clamp, and the wire goes almost directly into the box. On the right-hand side, you see a self-contained recept. And in this case, the securement happens to be a sleeve that it's passing through. And in both cases, the P-clamp on the left or the sleeve on the right, both are easily within 8 inches. And again, just to drive home the point, that the securement can be anything from that sleeve to the cable strap that you see with the nails in it on the right, or a P-clamp that you see on the left. You have the securement and or support as you would use if you had an actual stud sleeve doing the securement. So here's your straight line dimensions again. Again, it's from the corner of the device, in this case, your offset box on the left or your self-contained recept on the right. Closest point to the sleeves and closest point to the self-contained. And on the right, or I'm sorry, on the left side you see the arrows pointing to the corners of that self-contained box, and they're both within the 8 inches that you need to have. Now, the difference between the two is you really need to make sure that you leave enough extra loop in your self-contained receps rather than you do to the regular non-metallic boxes that you see on the left. And I'll explain that here in the next slide or so. The self-contained receps, when you need to pull them out of the wall to work on them, have to be 6 inches that can be pulled out of the wall. And we used to say that the 8 inches was added into the 6 inches and you had this 14-inch dimension. Well, the way the code basically reads is that your support, in this case the sleeve, needs to be a minimum of 8 inches. It has to stay within 8 inches. Well, if that stud sleeve is only 2 inches from the corner of the self-contained recept and you need to pull out a minimum of 6 inches, all you really need is 8 inches of cable. So that 6 plus 8 equals 14 is not really as important as it used to be. So that is true with what you're doing here. However, it's not necessarily the case when you're looking at a regular outlet. Your outlet that's just a plastic J-box, the important measurement is the 3 inches that you can pull the device out from the wall. As you see in the illustration on the left, you measure from the wall to the back of the, in this case, a receptacle, and if you got 3 inches, you're in good shape, and that's what we're going to worry about. So the amount of cable that actually comes out of the back and extends over to the first cable clamp has to be within 8 inches, but it could be as short as 8 inches. You don't have to have any extra to really pull out, okay? The only other thing that you could mention with this particular type of arrangement is instead of measuring the 3 inches from the wall, as you see on the left and on the right in real time, you can measure from the back of the boxes and use a 6-inch dimension. But in all cases, that 3-inch dimension from the outside of the wall to the device is necessary. You need to have the 3 inches. And that's really all that we have today. Very simple stuff, common issues that we deal with on a daily basis. And I appreciate you coming and watching this presentation.